Find iron-60, evidence for live iron-60 in meteorites. That tells you that the early solar system had to be in close proximity to a massive star that went supernova. And so that's the smoking gun. That if you went back 4.5 billion years ago and looked at the environment where our sun and solar system formed, you'd be looking at this kind of an environment. This is the cradle of the solar system.
Revelations like this have raised the stakes for servicing Hubble. The question is no longer whether to keep Hubble going, but exactly how.
And I would say that NASA's at a crossroads, and the crossroad is either we continue to go down the old path that we've always been locked into, or we start to develop new technology that's going to support future exploration, and Hubble is right at that juncture now.
Hubble will soon need servicing, so the robotic teams are in a race against time to prove that the technology works. In this test, the robot latches onto a large component, a camera housing, and pulls it out of its compartment.
We've got some tremendous advantages on our side in doing a robotic mission. One of the big limitations of a human-based shuttle-type mission is that we're very limited in the amount of time that astronauts can spend outside working on Hubble. It's very difficult, very taxing work, and typically we're allowed 5 days worth of spacewalks to do that. With robots, we can take a month or two, if necessary, to do all of the things that need to be done. The robots don't eat any food, they don't run out of oxygen, they don't complain. You know, they do what they're told.
Here at the Goddard Space Flight Center, engineers are honing the robot's fine motor skills, designing the specific tools needed to do the detailed work on Hubble. This is a test of the robot's very first operation. One arm reaches out and links up with Hubble's solar power generator. After a simple exchange of plugs from one socket to another, the robot can stay up and work for as long as it takes. The engineers have boiled the robot's work down to simple and efficient moves that use only a fraction of the tools brought along by astronauts.
A properly designed machine, a properly tested machine is always going to be much more reliable, much more dependable than any human being.
In the months ahead, the robotic teams will have to prove that the technology is advanced enough to risk on Hubble.
I think a robotic mission could succeed, but I think it's going to be a risky endeavor. On the other hand, developing that kind of technology will not just be useful for Hubble, it will pay rich benefits for NASA as a whole and allow science to put up other satellites far more distant orbits than Hubble and still service them.
If you want to demonstrate robotic technology, fine, demonstrate robotic technology. Do it on space station. But if you're talking about how you extend the scientific capability of Hubble, or rather how you extend on the scientific legacy of Hubble, how you preserve that essential capability, then robotic servicing is just not the way you do it.
The debate about Hubble's future will continue. Ultimately, the issue is not just how to keep Hubble flying, but what to replace it with.
3, 2, 1. We have ignition.
August 2003. The last of the great space observatories is launched into space aboard an unmanned rocket. The Spitzer Space Telescope points the way to the future of space astronomy. Technological breakthroughs allowed engineers to reduce its cost from estimates of $2 billion to a third of that. Not much more than it will take to send astronauts up to service Hubble.
It turns out that anytime you send men into space, it's expensive. That for something like the price of a single servicing mission to Hubble, sending the astronauts up with a couple of new instruments, putting them on the telescope, bringing them back down again, for the cost of a single one of those servicing missions, you could actually build a whole new telescope with a whole new couple of instruments that is more capable than an upgraded Hubble.
A series of replacements like this would join an ever-growing fleet of space telescopes that are scanning the heavens for new discoveries. Spitzer was designed to capture infrared light, to penetrate the mysterious center of our galaxy, see the birth of stars, and take us back to a time when the universe was in its infancy. Others carry out more specialized missions. Far out in space, a long time ago, an immense young star burns hot and fast. It dies in a blaze of glory, sending a burst of high-energy light shooting across the universe. Billions of years later, it reaches a remote outpost tucked inside the Milky Way galaxy. Scientists are preparing to capture it.
And we have liftoff of NASA's SWIFT spacecraft on a mission to study and understand gamma-ray bursts throughout the universe. Everything continues to look good as the Delta vehicle climbs.
The SWIFT Gamma-Ray Telescope, launched aboard a Delta rocket, is part of an unheralded string of successes. It is number 83 in a class of smaller space missions. The winning streak goes back 7 years, with 61 straight successful launches. Another will look at light from the earliest epochs of the universe. The James Webb Telescope is scheduled to launch in 2010. Even with an array of advanced technologies, it is expected to cost not much more than a shuttle servicing mission to Hubble. This telescope will look back to the deepest regions of the universe and probe new stars for solar systems in formation. Meanwhile, this golden age of great space observatories continues to roll on. Chandra is probing the most bizarre corners of the universe. It recently found a swarm of black holes in the center of our galaxy, lighting up and dimming as they steadily devoured companion stars. And in the center of a distant galaxy, it witnessed a supermassive black hole erupting in the largest explosion since the Big Bang. Hubble is hard at work as well. Its future may be uncertain, but its legacy is set. Hubble has whetted our appetite for discovery.
When Hubble originally flew, it was touted as being probably the biggest single advance in our ability to look at the heavens since Galileo first turned his small telescope on the sky. And that's turned out to be the case. The discoveries that Hubble has made in all fields of astronomy are quite simply mind-boggling. It has done everything that anyone ever thought that it might and more. And in fact, it has been so successful in what it has done that it has simply become part of the way that we look at the universe. The Hubble Space Telescope is an extension of the human spirit out into the heavens, pure and simple.